All right, so I thought I'd go over one problem real quick because a student came into my office hours and asked me about it, and I think when that happens, that's usually an indication that more people would be confused by it. So the question is, x and y are positive integers such that 3 times x plus y equals 40. Determine the values of x and y that maximizes the product of the two numbers. Okay, so it's an optimization problem, and if I were to write it out in terms of its equations. The first equation we know is that 3x plus y has to equal 40. And that x and y are positive integers. X and y are positive integers. Okay, that part's important. And what we're trying to maximize is the product. So if I'm kind of representing this the way I did for the optimization problems with you guys towards the beginning of the year, I would have said we want to maximize the product of two variables, x and y, only the problem is we can't work with two variables, not yet, not until we get to multivariate calculus, which is a long ways away. So what we need to do is isolate one of the variables in the equation, which I called the constraint, and substitute it into the other function. And so that you have a function that has only one variable that you can graph it and you can look at it. And in this case, it's going to be a parabola, and it's going to open down, and its vertex is going to be the point that maximizes the product. I know that. Only there is no guarantee that that point is actually going to be at two integer values. So we can look at it in a second. But sometimes when you have these optimization problems that specify that you're only working with integers, an easier way to do it than going through all of the formulaic approach is to just think of different number combinations that I could have that might make it work and see where that gets me to. So if I think of x is equal to 1, then I could deduce that y has to be equal to 37. And if I multiply them together, I'm going to get 37. If I think x has to be 2, then y has to be 34, and x times y would have to be 68. And I can see that the product is growing. So I want to continue going in that direction. And I should be able to continue going until I get a product that decreases. And then I know that I'm going to be at the right spot. So if x is 3, 3 times 3 is 9, y will be 31, this would be 93. If x is 4, y would be 28, x times y would be 112. If x is 5, 5 times 3 is 15, 15 plus 25 is going to give me 40. 5 times 25 is 125. If x is 6, 6 times 3 is 18. 18 plus 22 is going to give me 40. 6 times 22 is 132. If x is 7, 7 times 3 is 21. 21 plus 19 is equal to 40. 7 times 19, 7 times 20 is 140. So if I subtract 7 from that, I get 133. 8 times 3 is 24. 24 plus 16 is equal to 40. 8 times 16 is 128. So there, I've solved it. And now this would be x is equal to 7 and y is equal to 19 is the solution that I'm going to go with. If we want to look at what does it look like on a graph, what did I say was the function? It was 40x minus 3x squared. If I look at that, I get 6 2/3. And that kind of makes sense. So the product 133 1/3 is bigger than the 133 that I got at 7. So it peaks somewhere in between 6 and 7. It's closer to 7. It makes sense that your answer is 7. You don't need to do all the extra stuff that I've just showed you, but I just want you to have an idea of why it's sufficient to just use a table in this case, and that's because it specifies only integer values.